Now, electric
So where
field
you will be
is,
uploading this video?
yes, on the weekend, I guess.
No. On which platform? Like where will you upload?
Like on the website of Mega Lecture, you can find these videos, and some of the videos also go on online on YouTube.
Okay.
But if you register for the regular classes, we keep on sharing these videos in the group as well, so you can see them from there.
okay, so I got it.
Okay, because even if you miss a class, so for example, there are 2 or 3 more students in this class right now. They couldn't they could not get into the class right now, so they will be watching the video later. Now we will start with electric field. In the last class, we had an introduction about field, and we discussed that field is a region of influence around any non-contacting source of force. There is a field for magnet, there is a field force for charge, there is a field force for mass. Field force of mass is known as gravitational force or gravitational field. We have discussed that in the previous chapter, that there is magnetic field, which we will be discussing later. But now we are discussing electric field. And remember, electric field and magnetic field are very close to one another. The only difference is magnetic field is generated when charge is moving, and electric field is produced anywhere, whether it is moving or not. So both both fields, electric and magnetic, they depend on the charge particle. Electric field is region or space around a charge particle where it can exert an attractive pull or repulsive push force on other charges is called field of the charge, or in other words, electric field. Now, law of electrostatics. Number one, like charges repel and null-like charges attract. Like if you bring 2 different charges close to one another, they will attract. But if you bring a positive charge close to another positive charge, or you bring a negative charge close to another negative charge, they will repel one another. Number two, force of attraction or repulsion is directly proportional to product of charges and inversely proportional to square of distance between them. So pay attention. Force of attraction or repulsion. Two charges come close to one another, they can either attract or repel. Now, if they are like charges, they will repel. If they are unlike charges, they will attract. But the force of attraction or repulsion, the magnitude of force is regardless of whether there is attraction or repulsion. And magnitude of that force is directly proportional to product of the charges and inversely proportional to the square of distance between them. We are considering 2-point charges over here. This is also known as Coulomb's law. So if we have two charges, let's say this is charge number 1, Q1. This is charge number 2, Q2, and they are r meter apart. We take distance as r if we are talking about radial distance, regardless what is the direction of this distance, but it can be anywhere around charge Q1 or Q2. Now, excuse me, one more thing is that this distance r is from the center of Q1 to the center of Q2. It is not from the surface to surface. And because Q1 and Q2 are point charges, so they don't have a center. They are the center. Point charges mean that they are so small that they will be considered as a center, a single point. So where Q1 and Q2 are point charges, the force between them. So I'm not telling you whether they are like or unlike. The force between them is directly proportional to product. And force between them is inversely proportional to square of distance between their centers. So if we combine these two informations, we have a relationship between force Q1, Q2, and R square. So we can like understand that in what cases there will be an increase in force or decrease in force. That is crystal clear from this expression, but we cannot solve and find an exact value. We need a formula for that. We need an equation with an equal sign. And how can we introduce an equal sign? By introducing a constant on the right hand side. So we can make it F equals to K Q1 Q2 over R squared. So this is the expression for force, where K is a constant and its value depends on medium between Q1 and Q2. Unlike gravitational force, which is completely independent of medium or whatever there is between the two masses, the charges depend on the medium in between them. Like if we place two charges in vacuum and we put the same charges in air, and then we put the same charges in water, and then we put same charges in a solid, excuse me, the force that they exert on one another will not be exactly same. Although you keep the magnitude of the charges same, you keep the distance same, but because of the medium in between, there will be uh, difference in force, and that is because this K is actually a value that depends on a constant that depends on 1 over 4 pi epsilon. Now, what is epsilon? Like 4 and pi are understandable. This epsilon is a new thing. So epsilon is permittivity of free space, and epsilon naught is permittivity of free space of vacuum. So most of the time, the question that you're supposed to get in your exam, that will be about vacuum. Like charges would be placed in vacuum. So the value of epsilon you will be using is most of the time going to be epsilon naught. So K equals to 1 over 4 pi epsilon naught. And we can actually find the value of epsilon. Just 1 second. Let's open any paper. On the front page, we have here is this. Okay, so here we go. Okay, let's see what we have over here. So permittivity of free space, we will be only using permittivity of free space of vacuum, which is this. And because we most of the time use K, which is 1 over 4 pi epsilon naught, which is 8.99 into 10 to the power 9 meter farad, meter per farad. So this is permittivity of free space, and it is a constant, and you don't have to remember it, but we use it in this formula. So let's see, is there anything else we need to know about this formula? No. Let's use this formula to calculate something that will help us to remember the formula. Okay, now let's solve the question. two charges, Q1 and Q2, are placed in vacuum as shown in diagram. This is Q1 at point A. This is B. This is Q2. Q1 is 9 microcoulomb, or make it 9.0 microcoulomb, two significers, 9.0 microcoulomb, and Q2 is 6.0 microcoulomb. They both are positive. Because they both are positive, we can also predict what kind of force they will exert on one another. Will they attract or they will repel? Because they are like charges, they should repel one another. And they are 5 centimeters apart. So calculate force that Q1 exerts on Q2. Okay. Do you think you will like to give it a try? By yourself, or do you want me to solve it for you?
Yes, sir.
To solve this question, we simply put the values into the formula F equals to K Q1 Q2 over R square. And most of you gave an answer 194.184. There, don't you think you can present this thing as your final answer? Too many sig figs over there. So remember, your answer should have the exact number of secant figures as presented in the question. Okay, that is the easiest way. How many significant figure over here? 6.0, 2 figures. 9.0, 2 figures. 5.0, 2 figures. So it means I could have write 5, but I said 5.0. It means I'm giving you exactly 2 significant figures. And this is how I want my answer to be. The answer should also have 2 significant figures. Okay. So an answer like 194.184 falls in inappropriate number of secant figures.
So what if I just write 194?
That is also acceptable.
Okay.
I won't say that that is something examiner is going to penalize, but that is like you reducing it to 3 significant figures instead of 2. That is acceptable. One 194 and 190. 194 is 3 significant figures, and 190 is 2 significant figures. Confusion, anyone? Any questions? Nope. Okay. What is the toughest question that can appear? Challenge question. This is Q1 here. This is Q2. Yeah. This is Q. Q1 is a positive 0.0 microcoulomb of charge. Q2 is negative 0.75 microcoulomb of charge. Q1 to Q2. Okay, actually, let me just make a rectangle over there. This is a rectangle. Q1 is 0.50 and don't forget it is positive. Q2 is 0.75 microcoulomb of charge. This distance is 80 centimeter. This distance is 60 centimeter. And it is a rectangle. Okay. Number one, calculate. Number one, force on Q due to Q1 only. Q, on the other hand, is positive 1.0 microcoulomb. So force on Q due to Q1 only. Then we have to calculate force on Q due to Q2 only. 3. Resultant force on Q due to Q1 and Q2 . Okay. Is there anyone who can actually solve this question?
We'll have a try, sir.
Okay. What you can do is just take a screenshot and give it to you, because even if I move the screen, or sometimes what I do is that I solve the question without showing you to save time. So take a screen so I can take this screen away from here as well, if you want to do it yourself. uh, if you have taken a screenshot, be careful that Q2 is negative 0.75 microcoulomb. I remember that I wrote my negative 0.75 microcoulomb, but when I shifted the value over here, I forgot to put a negative sign. Somebody send me something?
Yes, sir.
Okay, your third part is incorrect. Rest is okay. You can rethink your third part.
Oh, okay. I think I figured it out. Yeah. Okay.
Because you're dealing with vectors, not scalars. So
Yeah, that's what I just thought.
Sir, is it minus 0.20? I think my one is mistake.
like I have no idea. You have to show me the working, and that is what I'm concerned with. So you're dealing with vector quantities, so you have to be good with these kind of things.
So I have just sent it in the group.
Sorry?
I got the answer 0.20. Wait. What?
I have no idea what the answer is. Okay, if you have a calculator, you can find out Fy and Fx, and the F that we are looking for will be square root of Fx square plus Fy square. So this will be your homework. You have to complete the question. We'll resume from the same point tomorrow. Till then, take care.